Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. Our topic for today is, I want my model to be deployed. Why is it so difficult? So it's a machine learning topic. Our today's speaker is Paul PETON, who is an AI MVP from France. My name is Satya Ramesh, and I will be the host for you for next few minutes. And Aarti Nambiar is helping me with moderation. Before we move forward, a quick word about who we are and what we do. We represent SQL Server Geeks and Data Platform Geeks communities, which were founded by Amit Bansal in the year 2010, under which we do a lot of free in-person event webinars, and we share a lot of free hands-on labs, free resources, etc., etc. So please follow dataplatformgeeks.com and SQLServerGeeks.com to get access to all our free content. And once in a year, we do this annual summit called Data Platform Summit in Bangalore, India. So we have been doing this from last 5 years, and this year it should be 6th year for us. You can see the themes of all past 5 years, 2015, 16, 17, 18, and 19. And we will be announcing 2020 soon as well. So here is a picture from recently concluded Data Platform Summit 2019, which happened in the month of August 2019 in Bangalore, India. So wherein people from 300 different companies traveled down from 16 different countries, attended this 100 plus sessions delivered by 50 plus speakers who traveled down from 20 different countries. So it's a massive summit which happens right in India. So if you're serious about my data platform, advanced analytics, or artificial intelligence, this summit is a must attend for you. If you wish to learn more about Data Platform Summit, you can simply visit dps10.com or else simply drop an email to contact@dps10.com. Here is a DPG core team: Amit Bansal, who is founder and president of Data Platform Geeks; Manohar Punna, who is a vice president; and you can see all other regional mentors from different cities across India and abroad. Here is the pictures of eDominant teams, which are helping us organizing all these free events. Special thanks to Microsoft for supporting our community efforts. And our today's knowledge partner is SQL Maestros. SQL Maestros is coming up with a lot of advanced video courses and hands-on labs. So I will talk about all these SQL Maestros offerings a little later. But if you wish to learn more about SQLMaestros.com, you can visit SQLMaestros.com. You're already a member of Data Platform Geeks. Remain as a member. You will be able to get access to all our free videos, labs, magazines, and all other learning resources as well. And if you have joined today's webinar using direct joining link, please go ahead and register so that you will be able to get the resources of today's webinar also. And please don't forget to add events at dataplatformgeeks.com to your address book. And please whitelist dataplatformgeeks.com domain so that you won't be able to miss any of our updates. And here is the bit.ly link again for you to save so that you will be able to access all our social channels. So without any further delay, over to the speaker. Paul, over to you.
Hello, everybody. Thank you very much. I'm very happy to be with you today. I'm not sure if it's a morning or for you in India it's afternoon. Here we're on the morning. I will share you my screen. Yes, perfect. Okay, let's go for maybe 1 hour, and after that Q&A. I want my model to be deployed. We are talking about machine learning, and I want to tell
Paul,
you.
sorry to interrupt.
Sorry.
Screen is not visible. Can you please reshare the screen once?
Okay. Sorry.
Yeah, perfect. We can see the screen now.
Should be better.
Yeah.
Okay. Sorry for. Okay, is it good for you? Can you see my screen? And now a picture of myself, I think. Yes, okay. My name is Paul PETON, and I'm a Microsoft AI MVP since 3 years now. And in France, I'm a meetup organizer with an association called Club Power BI. I think you know what this famous software in the Microsoft, which is Power BI. And I'm speaker for another meetup group, which concern the Azure platform. I used to be a data miner. I don't know if you remember this old buzzword. I don't know now if I'm data scientist or data engineer or data, what you want, but I love data. And today I'm a senior consultant in a French company called Azure. Nantes is a town in France. You can just have a look on the map, and it's famous for the elephant. If you want to see what's the elephant in Nantes, you can go to my YouTube channel and look at a demo of custom vision, how to recognize an elephant. Just one slide about my company in French, sorry, but we only, for the moment, we only work in France. What's the agenda for today, for this session? Very, very quickly, because you can find some resources on YouTube or other channels about machine learning, but I would like to, in 2 or 3 slides, to tell you the main concept about machine learning. And after that, we'll go to the new studio in Azure Machine Learning for just an overview, because today the main goal is to work with Python script, and to manage all the operations we need to do in the MLOps approach. So your new best friend after this session will be the Python SDK called Azure ML. And because script is not very easy to look at on a shared screen, I will make some demos, and you can download all the notebooks with the scripts on my GitHub. And to conclude, I will share you some examples of real Azure architecture that I do with my clients, and which integrate Azure ML service. So in a few words, what's the difference between AI and machine learning? If it's written in Python, it's machine learning. If it's written in PowerPoint, it's AI. It's just a joke. It's not from me, but I just want to focus on the fact that today we talk about industrialization of the machine learning, even if I use a PowerPoint to do that. And I will not talk about how to choose the best model for machine learning or how to optimize my model. It's really about industrialization. And in a few words too, what is supervised machine learning? If you are a developer, you can have some data, and you will write a script, a program, and with data and program, you can obtain an output, a result, which is the result you want to have with your code. But in machine learning, we reverse the process, and at the beginning you have data and you have some example of output. That means that you are looking in the past to see some result of today we are to give something really concrete. Today we are going to talk about diabetes. So maybe output, historical output, is the result of tests over people who are for diabetes. And with data and some example of outputs, the machine will automatically find the best way to go from data to the output. That's it's called program on this slide, but that's what we will call the model of machine learning. If you want to go further to all the supervised machine learning, you can have a look on the precedent Data Platform Geeks webinar. Now we are going to begin a data project, including machine learning. But in all data projects, you have, in my opinion, 4 common steps. First step, ingest. We have to take data. I don't know if it's on internet, if maybe on database, on premise, and we have to put it in a store that now we used to call a data lake, and with all the data on the store, we can run some script to compute, to maybe to do some data preparation, data cleaning, or machine learning, and finally we have to consume the result of our compute. But I would like to say one thing very, very important, and I say this at all my clients. If you forget the consume step, and consume step, it's maybe just a Power BI report, it's maybe a predictive model, as we will do today, maybe it's an app, mobile app, but if you forget this step, your data will only be a cost. Value, creating value, it's only in the consume step. So don't forget this consume step. Now, if we focus on the compute step in machine learning, you have to know that it's specific to machine learning, but we have to iterate on data preparation. And data preparation, maybe it's to find outliers, to correct some missing values, to choose to select the main features for the model. That's what we call the feature engineering and selection. After that, we train a model, and we have maybe 10, 20, 30 kind of models to resolve the problem that we have. And with a trained model, we have to evaluate the model. We do that with some metrics. Metrics is a numerical value to say if the model is good or not. And if we have a good enough model, we can do some prediction. And prediction is a step supported by what we are going to call a deployment. But don't forget that in the real life, we have to iterate on the feature selection, feature engineering, and the evaluation of the model. And if we go further into a model, I wrote a formula on this slide. AX plus B, it's maybe the simplest machine learning model, which is called a linear model. A and B are the parameters, but you will hear about hyperparameters, which can be the learning rate in gradient descent, which is a method to resolve the training of the machine learning model. But today we are focusing on the parameters. So parameters here are A and B. It is A and B are two numerical values, and we will save these values in a specific file which is called a pickle. It's a classical format for this file. It's serializable format, but we can use other formats for safe parameters like ONNX, H5 for deep learning, RDS for the R statistical R language. So why do we want to industrialize our machine learning? Because we have maybe to check the version of the model. We will later retrain the model because maybe our customer or people who have diabetes here are changing. So we have to retrain the model, and we have to find an old version. So we have to make backups. We want to planify the treatments. We want to monitor maybe the predict service. And in the real life, you have to integrate all this task in security, organizational security. And last thing, now with IoT, maybe we want to deploy the model on light terminals to do what we call the IoT edge. So why today is it so difficult? Maybe because we have some difficulties to talk with people that are data scientists. I include myself in data scientist. Sentence pronounced by the data scientist is, "It works on my machine." But okay, it works on your machine, but the training, you have trained a model on a laptop, maybe with only a part of the data. You have not all data from the data lake, because it's impossible to put all this data on your laptop, in the memory of your laptop. Maybe your training is a whole night long training, or maybe on several days. Maybe you have used some unknown packages in Python or R, and these packages will not be supported in the production environment. Maybe because you are working on different projects, you have some dependencies between the package of your projects, and you're not working in a distributed compute context, maybe like Spark. So it's not the same as maybe the production environment. So all these bullet points are some difficulties today to deploy a machine learning model in production. And what we need for production, we need many things, like a scheduler to plan data cleansing, data preparation. We need to plan training and retraining. We need to maybe to plan some batch of forecast. After that, we need some storage to store, to version the algorithm, an algorithm, a model is linked to the training dataset. So we have to version the model and its training dataset. We have to store the parameters. Remember the pickle file. We need a tool to expose the model, to deploy and expose the model, and it's easy today to do that with REST API, but we have to secure the access. And after that, we need a platform that can that can scale all the tasks, training task, but the deployment task too. If we have, for example, many people who are connecting to the REST API, we have to scale the resources, and it's easier if we do that in the cloud. So now I think we have a good solution which is called Azure Machine Learning. Maybe you remember another tool called Azure Machine Learning, sorry, in Microsoft. That's why I will call it the new studio. And we are going to look at on my screen. But in 2 words, Azure Machine Learning Service, it's a portal in the cloud, and SDK, and today I will only talk about the Python SDK, but you have to know that there is another one in our language, but I think that today Python SDK is more stable. And in Azure Machine Learning, we will prepare data, so we will build models and train it, but we will manage the models and deploy the models. So we have all the perimeter of machine learning in one Azure service. It's maybe if it's the first time that you look at Azure machine learning, maybe it's difficult to have a global vision of all the things that you can do in the new studio. But we will do that step by step in this talk. So let's go to the first demo. And as I said, the use case today is about diabetes because it's a very useful data set, open data set. The machine learning model that we will use is a linear regression. We want to predict the y value, which is numerical. So it's a regression. It's not a classification, for example. And to explain the y value, we have 10 features like age, sex, and more. So let me go to a web browser. Okay. I begin with my Azure portal. I'm in a resource group, and it's in this resource group I created one Azure Machine Learning service. This is this one, and you have to know that with this service you will have automatically one Azure Key Vault. That's for secrets, passwords, and passwords. You will have yes, it's a storage account because we are going to store some data on this service. And later I will talk about some container registry. Let's go on the Azure Machine portal. Maybe I can show you how to go. It's very, very easy because I go on the service and click on Launch Now, and now I'm here on the portal. On this portal, we are going to work with all the assets which are here, but to begin with Azure Machine Learning, the new studio, you have to create one compute instance. What's a compute instance? It's simply a virtual machine. If you click on New, you can choose the virtual machine size, okay, depending on vCPU and RAM. And when the virtual machine is running, we got 3 links to go to Jupyter Lab. What's Jupyter Lab? It's not a real IDE, but you can work with notebooks, Jupyter Lab, or just Jupyter. But I prefer Jupyter Lab, and sorry, I have to refresh. Okay, if you like the statistical R language, you can find R Studio. Lucky today because I'm trying to disconnect. Sorry, I will do that. And on the machine learning studio, after we created a compute resource, we can define some data stores. Data stores are maybe you can say links. I think links to two types of data storage. File storage like blob, file share, data lake, and database, the traditional SQL database of Microsoft, but some open source database like PostgreSQL and MySQL. Okay, let's go back on the slides. The use case is to model diabetes. Okay, but how to find the best model? It's not the main point today, but I would like to remember that data scientist, the data scientist job is 80% preparing data, and what's the 20%? It's complaining about the first order 80%. But today it's very easy to find the best model with what we are calling automated ML. So automated ML, you can do it with the Python SDK, and I will show you some script to do that. But if you are on the enterprise license, I go back on my portal and look at this. I'm in the standard license, and enterprise edition could give me two features more, which are automated ML, but automated ML in a UI, in a user interface. So you just have to click on some boxes. And the designer, is only the old Azure Machine Learning Studio. If you know this product is coming back, but it's in the enterprise license. So today we are only working with some scripts. So remember, automated ML free if you do it as a script, but enterprise feature if you want to use the UI. Here is an example of automated machine learning with Python SDK, but I will go very quickly here because it's not the subject of my talk today. Just have a look at some parameters. The task here in the configuration is a regression, but you can do, if you want, a classification for to predict a Boolean feature, or you can choose forecast. It's for time series. Time series, it's when you have at least two features. One feature is date time, and the other one is numerical value. With all this configuration, we launch the automated ML with one command, which is submit, and all automatically Azure Machine Learning will compare maybe 20 or 30 algorithms and give you in return the best one according to some metrics like I think we can see it here. The first one, for example, Spearman correlation is an evolution matrix, and you will have the best model for Spearman correlation. But it's not the main subject today. Today we are talking about MLOps, and MLOps it's how to do all these steps automatically, so with scripts. If we go back just a minute on DevOps. DevOps, it's to do some code and reproduce the code, to test automatically the code and deploy an app, which is maybe a mobile app or a website. In data science, in machine learning, it's a little bit more complex because we have to build and train the models. We have to make some tuning on the hyperparameters. We have to deploy, and all these steps are just the main things we have to do in the DevOps approach. So MLOps, if we want to define MLOps, we can talk about model reproducibility, model validation, model deployment, and model retraining. So if we have script, if we can write script for all these steps, it will be very, very easy to do MLOps. And I said that your new best friend is the Python SDK. On the last slide, you will find some links to the documentation, but it's very, very easy to find. And I will illustrate today three ways to go from the dataset to the deployment. That's the three notebooks I talk you which are on my GitHub. So Python SDK, it's a set of libraries to manage all the components of the Python of the Azure Machine Learning service, and to run all the steps like training, like deployment, and to monitor all the services. There's an official GitHub repo and the link to the documentation. It's free. I'm not sure if it's really open source, but it's free, and you can install this SDK with pip if you're working with Python. The last version is 1.2. But if you don't want to go to Azure Machine Learning, the new studio, if you're maybe you're not enough rights in your organization to create this service, you can begin with just a data science virtual machine, because the Python SDK begins to the preset configuration on this virtual machine. And when you will launch a new notebook in Jupyter Lab, you will have a Python version including Azure ML. In the Python SDK, we have many objects, but I would like to focus on the most important. The main concept is the workspace. The workspace is just your Azure Machine Learning service. And inside the workspace, we will work with some datastore, data lake, Azure SQL DB, for example, data sets in this data store. We will work with a compute target. I just show you a compute instance, just one VM, but we will work with what we used to call Azure Batch AI, so a cluster of VM. And we will run some experiments. Experiment, it's maybe a small or big pipeline of operation on the data, but the main operation here is training the model. And to train the model, we will need to define an environment to explain this concept, it's only the package, Python package, that we need, maybe like scikit-learn to do a linear regression. And inference and endpoint is what we need to deploy the model. Endpoint, we will simply an URL, an IP address to ask question to the model and to obtain a prediction. But all these objects are in the script in the next slides. First of all, I would like to go end to end with the most simple workflow we can do with the Python SDK. 6 steps. First step is to initialize a workspace. It's just one instruction to declare that you are working in a specific workspace of Azure. Second step is to create an experiment. It's just a new project. Here we are going to create the experiment about diabetes. After that, we declare a datastore, we upload on it a dataset, we train the model, and if we work with scikit-learn or with a format, model format like ONNX, or if we work with a TensorFlow framework, maybe for deep learning, it's very easy because it's called the standard way to work, and we can, after registering the model, we just have to deploy. You will see in the next steps that it could be a little bit difficult if you don't use the default model like scikit-learn. So the beginning of the script, I will go very quickly on the script slides because you can find it on my GitHub, but just have a look on this specific keyword. From config is just the way to link your script with the Azure ML service. Create an experiment. Okay, not so difficult. And if you run this script, you will have a link to go back to the portal, and I will switch on my browser. Okay, all is here. Experiments. It's diabetes experiment, and you can see that I will try it 9 times, and for 4 times it's complete. I can go back to this logs. I can see what is the evaluation metrics. Here it's the score of the model, and I can find here is hyperparameter. Regularization in linear regression is what we call the hyperparameter. Okay, the experiment is running, and at your first experiment, you have to declare the data store. So just to remember, supported data store are only on Azure, exception for Databricks, but it's Azure Databricks, what we call the DBFS, Databricks file system. Maybe you can imagine that it's a file system like, sorry, I don't remember the word. It's a metastore. Over maybe a data lake. So it's one message for Microsoft. We need an ODBC connector. When the data store is declared, we can upload data on the data stores and put the data set in the memory to work to train after the model. Be careful because it's a specific format in the Python SDK. It's called tabular, and you have to convert this tabular dataset to maybe some pandas data frame in order to work as usual with data frame in Python. I'm not speaking. I know that pandas is it's very difficult to work with big data. I will not speak about parallel compute in this talk, but you can see that Databricks could be a solution because it's a Spark environment, and you can install the Azure ML Python SDK on Databricks. It's supported. Okay, training the model. In this script, there's only Python script and nothing from coming from Azure ML. Classic script about machine learning, train, test, split. Okay, declare the model and fit the model. But you see here you can take an old script you have. It in Azure ML. And it's very important to understand that we are training the model on the compute instance. So compute instance is one virtual machine. It's here. It's just here one virtual machine, and we are running JupyterLab on this machine, and we are training the algorithm on this machine. So it's not very efficient if you have very big data or complex algorithm. To resolve this issue, we will later use training clusters. Which used to be called batch AI. Okay. So training, and after training, we register the model. It's an important step in the MLOps approach because now the pickle file is saved on Azure, and it's versioned. You can see the number of the version. I can go back maybe on the version of yesterday. Okay. And I don't know, I have no points, but you can find when this model is deployed, you can find the endpoint of deployment here. Okay, just so we register the model in the pickle format. That's just a screenshot. And last step, we are here. We have to deploy the model, and the easiest way to deploy the model is to use Azure Container Instance, and just one command here, which is deploy. And because it's a scikit-learn framework, it's very easy, just one command, and we deploy the container, and we can go back to the resource group in the Azure portal, and here is my containers instance. Okay. Be careful because all these services in Azure will generate some cost we have stored some Docker images. So be careful about the cost of this service. Okay, that's all for the first scenario, the simplest one. And with that, we have an endpoint, and an endpoint. Look at this; it's REST API. So we send some data to this REST API, and we get an answer. We can test the model with some code. Here is a sample of new data. We run the service with this new data, and we got an answer, a prediction. So first solution to deploy is ACI, Azure Container Instance, but there is some alternatives, because ACI is okay for a developer scenario. For production, we will use Azure Kubernetes service with a cluster of VM and more security options. But we can just try locally. We can launch a Docker environment on the virtual machine, and it will simulate the predict service. But we can, with this Docker image we generate, we can publish it on the Azure function, which is a serverless approach. Or we can do an Azure web app, which is maybe cheaper than AKS. So scenario number 2. Now we are not working with the default framework. We want to work with a custom framework. So here we have to change the way, and especially for the deployment, we need three things now. First is a scoring script. We need to put on the deployment endpoint, we need to put a specific scoring script. We need to put the needed packages on the deployment environment, and we need to define what we call the inference configuration. It's the size, vCPU and RAM of the deployment service. It's a little bit difficult. Here it's just a screenshot of the scoring script. But scoring script is 2 steps. First, to find the pickle model, and second step, to launch the predict function. You can give some decorators. It's examples of data's input and output to help the scoring function and to help the REST API. Now we have to define the environment. Remember that it's the deployment environment, the compute target environment, because we need to train the model. We need the scikit-learn package. Maybe we need pandas, numpy. If we do some charts, some plots, we need that plotlib. You can add what you want here, and there are 2 methods to do that. Working with some conda dependencies, or upload package with the pip install, classical pip install way. And all this script will define a YAML file which contain all the package you need. That's what we call the environment. Inference configuration, it's very, very easy because it's just one line of script with the environment and the scoring script. And now to deploy the model, we have to talk explicitly about Azure Container Instance configuration. For example, here I choose just one vCPU and 1 GB of memory. Maybe it's not enough. Maybe it's too big. So you can use one object of the Python SDK, which is the profiling function, which can find for you the best configuration in CPU and memory. It's a very, very interesting function. And to finish the deployment, we launch model.deploy with all this information of configuration. So end of scenario 2, it's a little bit more difficult because we have to produce some files, a scoring file, another YAML file for the environment, and we have to find the best configuration for the deployment. 2 or 3 screenshots about the local scenario because it's not so interesting, but just remember that you can do that if you don't want to generate another Azure resource. At the end, you can ask to this local web service, it's localhost and port to get the prediction. And last scenario for today, which is called the big data workflow, because here we will imagine that we can't train our model on just a little VM, which is a compute instance, but we have to train over a cluster, what we call the target compute. And to do that, we have to create, to define the compute target. It's a cluster of VM. We have to train the model, but it's a remote training. We have to go training on the cluster. And to do that, we have to create a training script. And one more time, we have to define the compute target environment. And we will use an estimator. What is an estimator? Is simply the configuration for the run, and we will have some widget to monitor the run on the cluster. Okay, just to create the remote compute target, you launch this script. What you will have is, sorry, this window. Okay, you will find, after that you will find your training compute cluster here. One tip, because you can see here that I use min nodes equal 0, sorry. And if you use the 0 value, the compute target will be deleted when node jobs are running on it. I think it's a good way to do some cleaning on your Azure resources. Now we define a train file. It's a .py file with all the steps we need to get the data, to train and split, to fit the model, and to save the model one more time in a pickle file. I just want to focus on this part of the scripts. Here I can define an argument. It's an argument of the Python script. And for example, here I used a regularization hyperparameter. And so to train, here it's not a simple linear regression. It's what we call the rich regression. And we give this parameter, this hyperparameter on the model. And another important thing to understand is that when we save the pickle file, we are going to save it on the remote cluster. Okay, and we can't go. We can't. Maybe with some SSH way, we can't go on the machine, but automatically the model will be saved in the Azure Machine Learning portal. I'm not sure to get it back, maybe on this run. Okay, yeah, some outputs, yeah, it's here. So here is my pickle file, because remember that it's we saved the pickle file on the remote cluster, but it's automatically duplicate on your Azure ML portal. So it's very easy to take the model and deploy it on maybe on SCI or on AKS. To run this remote training, we need to create an estimator. And estimator is just the way to launch my Python script, my training script. And you can see here that I give my regression hyperparameter to the script. Submit, okay, with this estimator, and it's running on the on the remote target. But we can monitor this run with a widget in the notebook. Here is a screenshot. It's just a better way to monitor. It's here's the logs, but it's you can go back to the studio, but it's easy to look to monitor the run in the notebook. And finally, we register the model. Don't forget that it's the remote model, but it's okay because it's automatically duplicated. Just 5 minutes more, maybe to present you some big pictures, how to go end-to-end with Azure Machine Learning. Here is recommended architecture by Microsoft, but I do prefer to show you some real project with my clients. Today, I work with this architecture with storage of the data, okay, ingestion with Azure Data Factory, some compute resource in Databricks, and I put the data in Power BI to do some reports, and in Azure Machine Learning to deploy a REST API, a predictive REST API. It's okay. I'm comfortable with this architecture, but maybe we have many Azure resources to create and to link. So what I will do soon, maybe this year, because now it's only on private preview, but I think that public preview will appears in this year. I will use maybe Azure Synapse Analytics, because in just one component we will find Data Factory, compute, the data warehouse for maybe some SQL queries, and a Spark compute context to do some Scala, PySpark scripts on a big amount of data. And after that, same two ways, go to Power BI or go to the deployment with Container Registry. So to conclude, what are the strengths of Azure Machine Learning? We are working in notebooks. I love notebooks because it's very visual, and we can, with a widget, we can supervise maybe the runs. All the parts of Azure Machine Learning are communicating together, and it's really easy to work with all these objects. We work with containers, which is today, I think, a standard way to work, and it's easy to finish the story with data in Power BI, maybe connecting Databricks to Power BI, or connecting, or use with Power BI Premium, you can use a machine learning model directly in Power BI Premium. But I think we can do better with maybe better way to do some data preparation. I don't know if you remember this Azure Machine Learning Workbench, because it disappears last year. But I think that it was a good tool to prepare the data. When we work with big ML pipelines, so many steps of preparation, of modeling, it's not very easy to do that only with script, because you don't have a visual way to understand the workflow. So remember that we have the studio, the old studio, now called the conceptor, the design conceptor. Yeah. It's not so easy today to to separate your environments if you want to have a development and production. I think that today we are going to duplicate the Azure Machine Learning service. Maybe we have to work with another language than Python if you want to go at scale with big data, and Scala could be the solution, but it's easy to do to work on Databricks. But remember that you can install the Azure ML SDK on Databricks. And if you prefer to stay with Python, have a look maybe on some packages to distribute the calculations. Okay, just to conclude, I think it's that the Python SDK and Azure Machine Learning Service are a very good tool for data engineers, because it's a full toolbox to industrialize, and data scientists can now spend times on exploring the data, choosing the best features, or interpret the models, or maybe it's just one people, data scientist and data engineer, and they are going to write only one script, and forget the approach of doing that the data scientist is doing the work one time, and after that data engineer is doing the work another time. You can imagine some other scenarios with these tools, like A/B testing. That means that today I've got a performant model which is in production, but maybe tomorrow with new data I will do better. So a better model, and automatically the better model will take the place of the deployed model. Maybe we can imagine some feedback loops. That means that people who are working with your predictions can say it's okay for me, or I think that it's wrong, and you can take this this feedback in the training dataset. Some ideas to go further. I think that you have to look at automated ML. You have to look at Databricks, maybe the SDK for R, but you have to know that we can do all these steps of MLOps with an API in Azure ML. If you want to register a version model, maybe you will have a look on MLflow, which is an open source project. And finally, have a look at the Interpret ML community, which is open source and Microsoft project, to give you some tools to understand what is in the black box of machine learning. Thank you for your attention, and let's go for Q&A if you want.
Hi, Paul. Yeah. Thank you for delivering a wonderful webinar. And before you take Q&A, I just have a couple of more slides.
Yeah.
I'll just share my screen. Meanwhile, I'll request all the attendees to post your questions using Q&A panel. I repeat again, please post your questions using the Q&A panel. Paul will go through all the questions in a minute time. Yeah, beyond this webinar, if you still have any questions, you can go to this web page using this bit.ly link called bit.ly/DPG social. You can go to a web page and join our social channels, and you can ask your questions there as well. We'll get the questions to Paul and get that answered. And as I mentioned earlier, a quick word from our today's knowledge partner, SQL Maestros. We thank SQL Maestros for sponsoring our webinar today. And SQL Maestros has come up with video courses on SQL Server performance tuning, T-SQL querying, and T-SQL programming. Right now, SQL Server performance tuning and T-SQL querying courses are live. You can directly go to sqlmaestros.com and you can go ahead and purchase. Right now, the good thing is SQL Maestros is supporting the community during these tough times by providing 50% discounts. And I guess you already know about all the video course benefits. So modular content, constantly updated, and the special thing about SQL Maestros video courses are it exactly feels like one-to-one teaching and feels 100% personalized. And these are high quality HD recorded videos, which you never find anywhere else. So directly go ahead to sqlmaestros.com and try to avail those discounts offered during these tough times. And SQL Maestros also has hands-on labs, which is a self-paced learning solution wherein you will be provided with a document with a step-by-step instructions followed by screenshot, explanation, observation, and scripts as well. So at the end of the document, you will be able to become master in that particular topic. So that is what hands-on labs is all about. And SQL Maestros is also offering 75% discounts right now to support the community during these tough times. So just go to sqlmaestros.com and grab all these offers. And without any further delay, I'll thank Paul PETON for delivering this wonderful webinar. And we had posted a thank you note for Paul for delivering this webinar, and links are available in chat window. We had posted in LinkedIn, we had posted in Facebook. Please go ahead and put up your comments. That will encourage our speakers to come back and deliver free webinars for us. So don't miss giving the feedback. That will really help our speakers to improve and come back and deliver sessions for us. And Paul, I'll hand it over back to you. So please go through Q&A panel. There are a couple of questions waiting for you.
Yes. Okay, I will share my screen. Oh, maybe it's not. Yeah. So first question about, three questions, sorry, about NLP, so natural language processing. The first question is how to store unstructured data with NLP. I think it's okay to store the data set on Blob, but you will have to do some preprocessing over your unstructured text to put that in tabular format. So in Python, maybe a data frame. So it's okay to store your text on a blob storage. It's okay to do that, but you will have to write some scripts to transform, to prepare your text and maybe extract, for example, name to do some named entity recognition. You ask me which is the best algorithm to work with NLP. It depends maybe about your goals, but in Azure ML Studio, you will find an old approach, which is Wopal Rabbit. I'm not sure that it's the standard for now, and you have to show, you have to look at maybe at some project like BERT, B-E-R-T, because you can you can use what you want from open source packages in the Azure ML platform. It's not only the Microsoft algorithm. So maybe have a look on BERT for NLP. I'm working at the moment with some text, unstructured text dataset, and we use a simple approach, which is TF-IDF, to find the best words to describe some TV shows, and we used a TF-IDF score to do that. Can you please elaborate? How should I orchestrate NLP? And last question about NLP, about architecture. I think you can use the same architecture as I showed before conclusion. Put your data in a data lake storage. Maybe use, depends on the amount of data, but maybe use a Databricks cluster to train to the NLP, and with the Python SDK on Databricks, go and save your models in Azure ML to deploy them after that with some solution like SCI or AKS. I hope that I hope it answers to your questions.
Yes, Paul. Yeah, I hope you have answered all the questions. And one more information for all the attendees. Data Platform Geeks is coming up with virtual symposiums in the month of May. So you can visit dataplatformgeeks.com and you can find out more details there. Series of like close in the virtual symposium that is happening in May 7th and 8th. There are close to 12 sessions happening on SQL Server 2019 theme. So just go to dataplatformgeeks.com and you can go ahead and register for free. All the virtual symposiums and webinars that Data Platform Geeks are doing are free. So just go ahead and log in and book your seat. And don't forget to give the feedback for today's webinar. The link is available in chat window. And once again, we thank Paul PETON for taking out his time during these tough times and delivering a session for Data Platform Geeks community. Thank you very, very much, Paul PETON.
Thank you. Thank you very much. Have a nice day.
Have a nice day to you too. Yeah.